lamprey? So, yeah, lamprey are eaten. I don't know how commonly they're eaten nowadays. Like, if you ever read like fantasy novels or like in Game of Thrones, lots of times one of the things they talk about is like lamprey pie, and they were once thought of as like a delicacy. I don't know that many people eat lamprey anymore. Claudia? Yeah, we're gonna start there. All right, so we didn't do the slide before. All right, so we got a lot here. So. All right, so fish, another adaptation fish have to life in the water is gills. And I'm sure you're familiar with gills. What is the function of gills, Ava?
They take oxygen out of the water.
Yeah, to take oxygen out of the water. They act sort of as lungs, although lungs are adapted to get oxygen out of the air. Gills are adapted to get oxygen out of the water. We call that gas exchange, taking in oxygen and removing carbon dioxide. In a fish's gills, the way the fish gets oxygen, it takes water into its mouth and then forces it out over its gills and then out through an opening on the side of the fish's head. And as that water is passing over the gills can sort of grab oxygen that's dissolved in the water and remove it so that the fish can use it for respiration. It also gets rid of carbon dioxide. And these gills are very thin, very fine, very delicate. That's why when you take a fish out of the water, it can't get oxygen anymore, because these gills, they sort of all collapse on each other. They need the support of the water to keep them all separated. And so there's a covering called the operculum that covers the gills because they're very delicate and could be damaged. It has this hard covering. If you ever go fishing, you can kind of hold that flap, that operculum up a little bit. You can see inside, you can see the gills there. If you ever catch a bunch of fish and you put them on those chains, you know what I'm talking about? You put it like the hook through the fish's mouth and it goes out through the gill opening, and then you clip it, and that keeps the fish in place. So that opening is there. So that's how fish get oxygen. Another thing fish have is this organ called the swim bladder. Now, if you think of a fish as like a submarine, does anyone know, like a submarine, how does it go up and down in the water?
A fish is just like a submarine where it goes up and down. A submarine will go up and down by its engine and how light it is.
Yeah, more, not so like, I mean, a sub can go down lower if it tilts and uses the engine to make it dive down, but it has another way of doing it. It has special tanks that it can fill with water or it can fill with air. So if it fills these tanks with water, what do you think happens to the submarine? It sinks. And if it fills them with air, then it rises. And fish has a similar kind of thing. It's called their swim bladder. It helps maintain their buoyancy, their ability to float in the water. They can put air into it, which causes them to float higher, or they could remove the air, which causes them to sink lower. It's kind of like if you've ever been trying to float in a pool. If you inhale really deeply, you could float very easily. But then if you exhale that air from your lungs, you start to sink. Same sort of principle. I'll tell you about this another point about the swim bladder in a second. In terms of circulatory system, this is something we're going to talk about for each class of vertebrates, how their circulatory system works. Fish have a simple heart that's made of just two chambers, an atrium and a ventricle. And the atrium takes in blood from the body, the ventricle pumps it out to the gills and to the rest of the fish's body. Now, I told you about that fishing boat I went on when I was in college. Another thing that happened on that boat is when we hauled the fish in and spilled them onto the deck, there were a bunch of fish that we caught that were sort of strange. They were dead, first of all. Their mouths were forced open, and they had like a bubble coming out of their mouth. What we realized then is that the reason those fish died like that is we had brought them up to the surface too quickly. Because fish have this swim bladder, and if they have air in it, a fish that's, say, 75 feet underwater, there's great pressure on that fish. Just like if you dive down to the bottom of a pool, like the deep section, how's it feel in your eardrums? It hurts, right? Because all that water is sort of pressing on in your eardrums, and you can feel that pressure. Well, imagine 75 feet underwater. There's even greater pressure. And so at 75 feet or wherever these fish were, the pressure was keeping the air in the swim bladder compressed. So normally as a fish would rise to the surface, it would let out that air slowly, because when you remove the pressure, it's going to increase in size. But if you force the fish up too quickly, it can't release that air. The air expands, and it crushes their internal organs. It even pokes out their mouth. And that's what that looks like. That's a fish whose swim bladder has expanded so much that it's actually poking out of their mouth. What?
It's not alive, right?
This fish is dead. I don't know where that picture came from. But that's what the fish looked like that I was referring to.
It looks like it's yeah, it looks like it's blue.
Yeah. No, fish don't like gum, so. All right. Oh, sorry. So let's talk a little bit about the anatomy of a fish. So when we talk about animals and their anatomy, we have some words we use for the different sides of an animal. The back side is called the dorsal side. The belly side is called the ventral side. Those are like general anatomy terms. The head end is called the anterior. The back end is called the posterior as well. So if we look at this fish, fish do have nostrils, but they're not used for what?
Breathing.
Breathing. So fish don't breathe through their nostrils. They breathe by taking water in their mouth and out through their gills. The nostrils are used for smell. Fish smell like we smell. We smell because in our nasal cavity we have receptors, and when certain molecules are in the air, they bind to the receptors, and that tells our brain that there's a certain smell. Same thing in the water. Fish can sense chemicals in the water, and that's how they smell. Fish have, obviously, eyes that they use. Often fish have eyes are on the lateral side of them, so that they can see a very wide area peripherally. You can see almost 360 degrees. But they don't have great depth perception to see how near or far something is. Animals with good depth perception usually have forward-facing eyes. Fish have eyes on the sides usually. This fin on the top, it's called the dorsal fin, because it's on the dorsal side of the fish. This fin in the back, called the caudal fin. It's often used to propel the fish forward. Also these pectoral fins, just behind the gills, uses to sort of maneuver in the water. There's other fins, there's pelvic fins and anal fins as well, but we're not going to get into all those details. You have the lateral line to sense vibrations in the water. We have the gill cover to protect the gills. It's also called the operculum. Then if you look to the inside of the fish, if you were to sort of look inside of the fish, you would see this. So again, same thing, we use these terms, dorsal, ventral side. The fish's brain is located sort of on the dorsal side of the fish, just behind the eyes. Fish have a pretty small brain. Linked to this long thing, what is this? Okay, that's the spinal cord of the fish. It takes information from the brain down to the other parts of the body and brings information to the brain. Oh, there's two lines. This one, the second line is the brain. And then this is the spinal cord. The swim bladder's in here. See that? Color it in blue. And so again, when we forced those fish to the surface so quickly, it expanded and came out poking through the mouth. The heart's down here. It's on the ventral side of the fish. It's just below the gills usually. Yeah, it's pretty small. And again, it's a simple heart. It has an atrium that takes in blood and then a ventricle that pumps it out. Atrium is this first chamber, this middle arrow. And then you have the gills that are here. And they're sort of behind. What do you think this is? What are all these things? Nope. What do you think needs to be right near the gills?
Lungs.
They don't have lungs.
That thing that you guys are talking about.
Where does the oxygen go from the gills?
The mouth.
No.
The air bladder.
No, it's on the outside.
So listen, the fish absorbs oxygen from the water. How is that oxygen going to get all throughout the fish's body? How does oxygen get through our body? In our blood. These are blood vessels. They take the oxygen from the gills and then can transport it to the other parts of the body. The stomach is in here, along with the intestine to digest food. And then these blood vessels carry that blood back and forth from the heart to the other parts of the body. All right, so that's fish. Fish are adapted to life in the water. Like I said, fish were the first vertebrates that evolved. From a group of fish, then, at some point evolved amphibians. And that's what we're going to talk about next. Amphibians. What makes amphibians different from fish? Raise your hand, please. Raise your hand, please. Ethan?
Some species are on land.
Yeah, that they can spend at least a portion of their life on land. Fish are confined to the water, right? They have gills only. They have to be in the water. Amphibians evolved to be able to move away from the water, at least temporarily. The name itself, amphibian, comes from two parts, ampha and bios. It means double life. Because many amphibians go through metamorphosis in which they have two very distinct phases to their life. And you probably are familiar, what is an example of an amphibian that has two stages to its life? Ava? A frog. What's the early stage? Yes, which eventually matures to an adult frog. And so oftentimes with these types of amphibians, the larva stage is very much looks like a fish. You don't have a blank for that. You can just write the larva or fish like. You know, if you were just to see a tadpole, you may mistake it for a fish. So give me some examples of amphibians.
Turtle.
Toads, not turtle.
Salamanders.
Salamanders,
Lizard.
those are reptiles. Luke? A new? Yeah. Frogs, which have smooth, moist skin usually, long hind legs. Many of them live in moist areas. Toads, which often live in drier areas, have drier skin, shorter hind legs. Then salamanders and newts, which usually retain tails in the adult stages. And then there's one sort of interesting amphibian called the apoda, which is actually blind, can't see, and it has no legs. It just almost looks like a worm. I'll show it to you in a minute. So here's some examples. You know, poison dart frog, a toad, okay, salamanders, tree frog.
Tree frogs are so cute.
What is that ugly thing?
No, tree frogs are not.
Looks like my mom.
We saw.
Right there.
All right, guys. Listen. If you have a question, raise your hand. Ethan. So we saw. I went to Costa Rica a few years ago, and I'm going again this spring. And we saw these tree frogs mating. Kind of interesting to see. This is the apoda.
Ew, gross. That's so gross. It looks like a big one.
That's like a big fire belly. So there's lots of interesting colors. Some are poisonous. Claudia?
They have
Shh.
to like take the frogs and like throw them over the fence because they like lay eggs.
There's so many of them. Yeah, we'll talk about reproduction in a second. So amphibians, unlike fish, what did fish have as a body covering? Scales. Amphibians have a thin skin as their body covering. And their skin is important because they can actually breathe through their skin and absorb water through their skin. Like fish, amphibians are also cold-blooded. They don't regulate their body temperature internally. Their body temperature depends on their surroundings. Again, you're not going to see lots of amphibians around in the middle of the winter in our area. Even though they're here, okay, you're not going to see them. Yes.
Aren't frogs just like humans like us?
In terms of their organs?
That's
Yes. Yes.
Where did I second from?
All right. In terms of reproduction, amphibians have very similar means of reproduction to fish. They have external fertilization and external development. So again, the female releases eggs, the male releases sperm onto the eggs. The sperm cells fertilize each of those eggs. The eggs are usually coated in this sort of jelly-like coating. Keeps them pretty close together. It makes fertilization more likely because all the eggs are sort of one contained area. We'll talk more about those eggs in a minute. Grace? Yeah, in Massachusetts? No.
And all these like fish eggs were hitting us, and it was so gross. But then we caught some, and we
They could have been frog eggs. A lot of people will collect frog eggs and let them hatch and stuff. So fish had how many chambers in their heart? Two. Amphibians have 3 chamber hearts. They have 2 atrium, a right and a left atrium, and 1 ventricle. This helps keep oxygenated blood more separated than deoxygenated blood. And that helps get as much more oxygen to the body cells versus a 2-chambered heart, which the oxygen-rich and oxygen-poor blood mix together a lot.
Why is it right and left?
Because you always talk about anatomy as if it's in the animal. So if that were me, and you're looking at my heart, it's my right hand, that's my right atrium. Okay? Like this is my right ear. That would be my right atrium. This is my right egg, even though to you, I'm pointing, when you're looking, it's the left. Amphibians can breathe in several ways. They can breathe directly through their skin because it's very thin and the underside is filled with blood vessels to absorb oxygen. Some amphibians have gills, especially in the young stages. In the larval stage, for example, as a tadpole, they have gills to breathe. They live in the water. They absorb oxygen out of the water. Lungs develop often in the adult stage, and that's when the amphibian can move out of the water onto land, can breathe air. So, how many people have collected tadpoles? Did they hatch into, how many people collected frog eggs? Anyone do that? Okay. How about tadpoles? Did they grow into frogs?
Yes.
I didn't feel that. I don't
Yeah,
know.
sometimes they do. Other times when you hold on to tadpoles, they stay in that larval stage for a while. It sort of depends on the conditions. So frogs go through a process of metamorphosis, kind of like a butterfly. Would you call it complete or incomplete? Complete. They look quite different from the larval stage to the adult stage. Hold on. So we start off with the egg stage. Again, frog eggs are covered in that jelly. They hatch into what looks like almost fish, called tadpoles. They have a tail for swimming. They have gills to get oxygen out of the water. They have no limbs, so they look a lot like a fish. But as those tadpoles grow and develop, they start to change. What are the changes that happen to a tadpole? Grace? It grows front and back limbs. What else? Its tail gets smaller and smaller. Mia?
It doesn't have gills.
Its gills disappear and are replaced with lungs. Okay. All those changes happen as that larval stage is growing into the adult stage. The smallest version, when we still have a frog with lungs, but still a little bit of a tail, we call it froglet. And eventually it reaches the adult frog stage.
You broke your pen.
What are those pictures? Where did she get it from?
So, last slide. As you know, and you guys just sort of mentioned, around here, you don't see amphibians because they are hibernating. They're going into sort of a dormant state over the winter in the ground somewhere. Often they bury themselves in the mud.
Yeah, I tried that.
And they can stay alive. They still need energy. Even though their bodies are basically not doing anything, they still need energy to stay alive. Where do they get that energy? They're not moving around, they're not eating anything. They've stored up energy, correct. And they don't quite store food, but they take the energy, excess energy they were eating during the spring and summer, and they store it inside their bodies in a organ called the fat bodies.
What is that from?
So this is a frog that's been dissected. These orange things that you see inside of this frog are the fat bodies. This is a frog that was eating very well before it died. It has lots of fat bodies. As this frog would hibernate, it'd be using up the stored energy to keep it alive. As the winter would go along, these fat bodies would get smaller and smaller because it's using up that energy. So they store their extra energy in fat bodies. And like we were talking about earlier, mammals store extra energy as well, not as fat bodies like this that are internal, but as in body fat that's underneath the skin. Zach?
Aren't we gonna have to dissect the frog?
Yeah, eventually you will. All right, so the final thing to talk about today is a little bit more about the reproduction. So frogs have external fertilization in the water usually. It happens often in the springtime. In an area like ours, most animals reproduce in the spring. Why in the spring? Jordan?
Because in the springtime is when it's a whole new season for them, and they can grow and they can live out a little bit more longer.
Yeah, and there's more food starts to become available. They'll have the whole summer and fall to grow until they have to hibernate again. Amphibians release fewer eggs than fish, often like in the hundreds. Remember, fish are often thousands or tens of thousands of eggs at once. And those eggs are surrounded by that jelly-like coating that keeps them sort of together all in one place.
That looks really cool.
I don't know, we'll collect them and try and raise them into tadpoles and frogs. And each of those little black dots would be a frog embryo starting to grow.